and that lies in between the maximum and minimum of these values. Okay, मतलब ये x का जो वैल्यूज है, x का जो वैल्यू है, वो वैल्यू अगर ये जो गिवन वैल्यूज x0 x1 x2 xn इसके अंदर में लाई करता है, ओके इसके अंदर में लाई करता है मतलब मिनिमम ऑफ दिस वैल्यूज टू मैक्सिमम ऑफ दिस वैल्यूज के अंदर लाई करता है, अगर ऐसे होता है देन इट इज कॉल्ड इंटरपोलेशन. Note that in interpolation, x should lie in between these given values. Okay, तो अगर x जो वैल्यू पे f का वैल्यू पूछा गया है, फंक्शनल वैल्यू पूछा गया है, वो अगर इन बिटवीन लाई करता है, इन बिटवीन द नोड वैल्यूज लाई करता है, तो उसको बोलते हैं इंटरपोलेशन. एंड अगर वो x वैल्यू वो टेबल वैल्यू से बाहर होता है तो इसको बोलते हैं एक्स्ट्रापोलेशन. तो मतलब ये देखो, ये प्रॉब्लम मैं दिखा रहा हूं. गिवन दैट दिस टेबल, fine, this table is given and it is asked to find f at 2.7. Now it is a problem of interpolation not or extrapolation. So interpolation means what? ये 2.7 जो वैल्यू है, ये वैल्यू चेक करो कि ये x का जो रेंज है, टोटल जो वैल्यूज है मतलब 0 2 4 6 8 10, तो इसमें सबसे छोटा है 0 एंड सबसे बड़ा है 10, तो दैट इज द रेंज. ओके, that is the range where the values of x lie and 2.7 lies inside the range. मतलब ये 0 to 10 के अंदर lie कर रहा है 2.7, right? मतलब just after 2 means in between 2 and 4, ये यहाँ पे lie करेगा कहीं पे 2.7. तो ये क्या होगा? ये होगा interpolation, right? Because the asking value, it is lying inside the table. ये टेबल के अंदर है, मतलब एग्जैक्टली टेबल में नहीं है, बट टेबल में जो नोडल वैल्यूज है उसमें उसके अंदर है, उसका मतलब उसका रेंज के अंदर है, ये बोल सकते हैं. हियर द रेंज इज 0 to 10 एंड इफ आई आस्क फाइंड एफ एट say 11.2. okay, if at 11.2, then 11.2 you see that value of x does not lie in the range. 0 to 10 में लाई नहीं करता, ये 10 के बाद आता है, 10 के बाद आएगा 11.2 कभी कहीं पे, राइट? so it is not lying inside the range. so that is why to find f at 11.2, the method we are going to use, that is called extrapolation. okay, are you getting?
Yes, sir.
Yes, sir.
Fine. Now the question is how to परफॉर्म दिस इंटरपोलेशन मेथड. मतलब ये तो पता चलेगा कि हाँ इंटरपोलेशन ये होता है, बट व्हाट इज द प्रोसेस इन इंटरपोलेशन, दैट we are going to see. So in interpolation what we do, we approximate the function. Look, y is equal to fx, we don't know that function fx, only I know some functional values, right? Only I know some functional values of f, but exactly I don't know what is fx. that may be any मतलब transcendental function, any trigonometric function, or maybe any polynomial or anything, मतलब I don't know, I have some values only. So what we do, always we approximate that function fx to a polynomial. मतलब ये fx के corresponding हम लोग एक polynomial construct करेंगे, जो polynomial क्या होगा कि जो polynomial agrees f at the same values of x. मतलब ये fx का x नॉट पॉइंट पे जो वैल्यू है, ये px का x नॉट पॉइंट में वही वैल्यू होगा. मतलब ये कंडीशन pn xi is equal to fxi for all I 0 1 2 3 n. तो ऐसे एक पॉलिनोमियल हम लोग कंस्ट्रक्ट करेंगे जो पॉलिनोमियल assumes the values of x. ओके, तो यही मेन आइडिया है कि हम लोग यहाँ पे वी आर गोइंग टू कंस्ट्रक्ट ए पॉलिनोमियल corresponding to the function. Now once we construct the polynomial, then we can find any value, right? मतलब अगर पी एन एक्स जो है ये अगर मिल गया, सपोज ये बन गया 2x² प्लस 3x प्लस 9, ऐसे कुछ एक पॉलिनोमियल बन गया बाय सम मेथड, इंटरपोलेशन मेथड. So if we got this, then after that finding any functional value at some point, we can do it. मतलब p n x का वैल्यू कुछ भी दो, मैं वैल्यू बोल सकता हूँ कि वो वैल्यू क्या होगा, right? So if I know this, then we can find any functional value. So how to construct that polynomial? That is the question. How to construct that polynomial? Here we are going to construct a polynomial corresponding to the given table. मतलब ये जो टेबल है, टेबल के हिसाब से हम लोग एक पॉलिनोमियल बनाएंगे. वो पॉलिनोमियल बनाने का देखो एक मतलब रूल है. व्हाट इज द रूल? इफ देयर आर n प्लस 1 नोड्स, इफ देयर आर n प्लस 1 नोड्स, नोड्स मतलब n प्लस 1 x वैल्यूज, ओके. तो जो पॉलिनोमियल बनेगा, दैट पॉलिनोमियल वो पॉलिनोमियल का डिग्री बनेगा एटमोस्ट n, एटमोस्ट n. So if we have been given n plus 1 number of nodes and n plus 1 number of functional values, then we can construct a polynomial of degree at most n. We cannot construct a polynomial of degree more than that degree. मतलब we cannot construct a polynomial of degree more than n. Okay. So that is a logic, means that is the main thing here which we are going to use. We are going to construct a polynomial of degree at most n by using the n plus 1 number of nodes. There are several methods to construct that polynomial. Actually different scientists or mathematician, they gave their own rule to construct this polynomial. So there have at least 7 8 that interpolating polynomial, I mean 7 8 methods to find that polynomial. Okay, 7 or 8 method, more than that. But you have only actually 2 methods in your syllabus to construct that polynomial. So the methods are Lagrange's interpolation and divided difference interpolation. These 2 methods only. So here it is an existence and uniqueness condition of interpolating polynomial. मतलब कोई भी एक फंक्शन के करेस्पॉन्डिंग इंटरपोलेटिंग पॉलिनोमियल जैसे बताया वैसे पॉलिनोमियल एग्जिस्ट करेगा, इसका क्या क्राइटेरिया है. मतलब ऑलवेज कोई भी एक गिवन टेबल के हिसाब से हम लोग क्या एक पॉलिनोमियल बना सकते हैं. तो उसका आंसर देगा ये थ्योरम. ये थ्योरम क्या बोल रहे हैं कि एवरी फंक्शन एफ एक्स विच इज कॉन्टिन्यूअस इन ए क्लोज इंटरवल ए बी कैन बी रिप्लेस्ड बाय पॉलिनोमियल पी एक्स टू एनी डिजायर्ड डिग्री ऑफ एक्यूरेसी सच दैट एफ एक्स माइनस पी एक्स मॉड्यूलस लेस देन एप्सिलॉन. मतलब क्या है? मतलब ये बोल रहे हैं कि अगर फंक्शन जो एफ एक्स वाई इज इक्वल टू एफ एक्स फंक्शन का बात कर रहे थे, जिसका जिसके करस्पॉन्डिंग हम लोग पी एक्स बना रहे हैं, ये फंक्शन अगर कॉन्टिन्यूअस है, इफ वी नो दैट द फंक्शन इज कॉन्टिन्यूअस in a closed interval, then only we can construct a polynomial of desired degree of accuracy. मतलब कोई भी डिग्री का हम लोग पॉलिनोमियल बना सकते हैं. डिजायर्ड डिग्री ऑफ एक्यूरेसी मतलब कोई भी सुइटेबल डिग्री का. बट वो डिपेंड करता है कि कितना नंबर ऑफ नोड्स है। जैसे मैंने बताया कि इफ देयर आर n प्लस वन नंबर ऑफ नोड्स वी कैन कंस्ट्रक्ट ए पॉलिनोमियल ऑफ डिग्री एट मोस्ट n और n से कम। So desired degree of accuracy maximum up to n. Only condition is that fx would be continuous. अगर fx continuous है then we can replace it by a polynomial. Now the first method to construct that polynomial which is called interpolating polynomial. मतलब ये y is equal to fx टेबल, इसके रिलेटेड जो टेबल है वो टेबल के हिसाब से हम लोग जो पॉलिनोमियल बनाएंगे ये पॉलिनोमियल को बोलते हैं इंटरपोलेटिंग पॉलिनोमियल। ओके, इंटरपोलेटिंग पॉलिनोमियल, that is the main task here to find interpolating polynomial corresponding to the given data. Now see, in Lagrange's interpolation what is the rule to construct then that interpolating polynomial? So I'm writing Lagrange's interpolation. So we are taking let a function, rather a continuous function, y is equal to fx is known for n plus 1 number of n plus 1 nodes. Okay, and we are denoting those nodes as x0, x1, x2 up to xn. So मतलब ये n plus 1 number of x वैल्यू के लिए y वैल्यू दिया है, that we are assuming initially, that is we have been given the table this x fx, तो x का वैल्यूज है x0, x1, x2 up to xn, and functional values. So functional values means y is equal to fx में x का वैल्यू अगर x0 पुट करेंगे तो जो आएगा that is the functional value. So you can denote it by yi or you can denote it by fi. मतलब f at xi that is the functional value and you can denote it by fi or you can denote it by yi. Fine. So here what I have taken fi. I have taken fi. So I am writing fi. So if not f1, f2, these are what? Functional values at these nodes. Fn. Are you getting what are these values? f0, f1, f2, fn. मतलब ये fx का वैल्यूज है ये नोड्स पे, ठीक है? These are given. In question also you will be given this type of table. Fine. Am I audible?
Yes, sir.
Yes.
Yes, sir.
Okay. तो here the interpolating polynomial. What is the interpolating polynomial? you see what is the rule? Interpolating polynomial, which is the approximation of what? fx. fx को approximate कर रहे हैं as a polynomial and we are denoting it as lx. ये जो पॉलिनोमियल है, यूजुअली पॉलिनोमियल को हम लोग px और pnx ऐसे डिनोट करते हैं, and here we are denoting it as lx. why lx? lx is for Lagrange. okay, Lagrange polynomial के लिए lx. तो lx and the rule is k 0 to n lk x divided by lk xk into fk. So that summation gives us the polynomial, okay, which we need. Now what is that lkx? Fk, that we know, fk means that values are in the second column, sorry, second row, f naught, f1, f2, these are the values of fk. Here it is a summation runs over k to k0 to n. तो k0 मतलब f naught, k1 मतलब f1, k2 f2, that is known. Now we need to know what is that lkx. So I am writing what is lkx, where lkx means the product of all linear factors corresponding to these nodes x0, x1, x2, xn except x minus xk. So x minus x0, x minus x1, x minus x2, x minus x a minus 1, x minus x k plus 1 dot 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 x minus xn. तो देखो, there have n plus 1 number of nodes, and corresponding to each node you can construct a linear factor x minus that node. तो x minus x naught हो गया, x minus x1 हो गया, x minus x2 हो गया, up to x minus xn. So you form linear factors corresponding to each node, then you multiply them. Means we are taking x minus x naught into x minus x1 into x minus x2 into x minus xn. But here it is not all, it is not the product of all the linear factors, is it? मतलब ये क्या है बोल सकते हो, product of all the linear factors or something is missing? What is missing here? As I told, what is missing? Or I have written all the factors.
Sir, x minus xk.
Not audible again.
Sir, x
Some problem.
minus xk.
Laptop, I think.
Sir, am I audible?
Okay. So it is basically what? A product of n number of linear factors. What is missing here? Which factor is missing? You see here, x minus xk is missing, right? I have not written x minus xk.
Yes, sir. Sir.
So one factor is missing. And overall, how many how many nodes are there? N plus 1 number of nodes. So corresponding to n plus 1 number of nodes, there should have uh, n plus 1 number of linear factors, but we have ignored one linear factor. So it is a product of n number of linear factors. मतलब n plus 1 number of linear factor था, उसमें एक factor नहीं है x minus x के, तो ये product of n linear factors है. It is of degree n. LKX का degree जो है, whatever the value of k is, the degree of it is n. If there are n plus 1 number of nodes, then the degree of the polynomial LKX, it is also a polynomial, is of degree n. Now you see, I'm showing you some particular LKX for particular value of k. Say for k is equal to 0, if I take k is equal to 0, then what is LKX? मतलब L not x. So what I will write? Which factor is missing? That you have to see. We have to write all the linear factors except one. And what is that? L not x में x minus x not नहीं रहेगा, right? L के x में क्या है? x minus x के missing. x minus x के missing. Here L not x में क्या missing होगा? X minus x not, right? तो it will be this x minus x1 से लेके जितना है सब. This. It is also degree n. Now L1x. That means which factor is missing in L1x? X minus x1. Right? Sorry. Yeah. X minus x1 is missing. So what I write? X minus x0 रहेगा. उसके बाद x minus x1 वो नहीं रहेगा. Then x minus x2, x minus x3 and x minus xn. Right? Similarly L2x में x minus x2 factor that will be absent and others you write. Okay. So I hope all of you got how to construct that L0, L1, L2. Next is that LKXK. So if you know LKX, then you put x equal to xk, you will get LKXK. Like here, if I want to write L1 x1, that is LKXK form, na? LKXK. So what is L1 x1? So in L1x, you put x equal to x1. That means x1 minus x0, x1 minus x2, x1 minus x3 up to x1 minus xn. That is LKXK, 1 LKXK. It is a constant. You see x1 and x0, they are constant values. x1, x2 constant values. So LKXK, these values are constant. But LKX, it is a polynomial of degree n. So what ultimately we are doing, the sum of this LKXK divided by LKX divided by LKXK multiplied FK. समेशन है. तो k 0 to n मतलब 0 के लिए एक टर्म, फिर k1 के लिए और एक टर्म, k2 के लिए और एक टर्म, up to kn के लिए और एक टर्म. So how many terms are there in that summation? How many terms? 0 to n. So n plus 1 number of terms. So what you have to do ultimately after finding these values, LKX, LKXK, you put it and then you expand the summation. So ultimately you have to add n plus 1 number of terms. Okay. You have to add n plus 1 number of terms and simplify, you will get the polynomial of degree n. And here it is a small observation. It is not needed, or you no need to write whenever a numeric problem will be given. It is an observation. If you consider that whole coefficient as LKX, okay, we are assuming LKX equal to LKX divided by LKXK. Then if you put x equal to here, if you put x equal to, okay, I'm writing in a side, then it will be clear. What is LKX? What we have assumed, it is LKX divided by LKXK. Okay. Now, if we put x equal to XK, means capital LK XK, what it will be? So here in that place x, we have to substitute it by xk. So LKXK divided by LKXK, it will be 1. So it is the case, actually in general I am writing LKXJ. If j is equal to k, then it is 1, right? J is equal to k means LKXK ही हो रहा है ना. So LKXK it is 1 whenever k is equal to j, and if that j is not equal to k, means if you take other than xk, it will be 0. Okay, other than xk, it will be 0. So that is an observation. Now, see, I am showing you a particular case. एग्जाम में ऐसे n plus 1 number of nodes के लिए नहीं आएगा, in general नहीं आएगा. n का वैल्यू मे बी 2 और मे बी 3 अप टू दैट ऐसे ही रहेगा. मतलब नंबर ऑफ नोड्स कितना दे सकता है, मे बी एट मोस्ट 4. So it is a particular case I am showing. Whenever n is equal to 2, n is equal to 2 means how many nodes? x0, x1, x2, right? x0 से लेके xn तक ये होता है nodes. तो n is equal to 2 means 3 nodes, x0, x1, x2. So we are assuming that 3 nodes are given, and functional values at these nodes are given. Means we have been given this table, a small table. Fine. तो 3 node है, and वो 3 node के corresponding functional values this. So what will be the Lagrange's interpolating polynomial? So it is denoted as Lx. We can denote it by Lx. मतलब यहाँ पे मैं P2 लिखा हूँ, but you can write P2, you can write Lx, whatever. मतलब ये तो एक polynomial का notation है. तो as I told, in case of Lagrange's interpolation, you take Lx, but you can write P2x also. क्योंकि n2 है तो P2x भी लिख सकते हैं. Now, what is the main rule here to construct Lagrange's polynomial? So you apply that formula. What is the formula? Lx equal to summation k0 to infinity. Is it infinity? No. K0 to n. N means 2. Lkx divided by Lk xk into fk. Okay, I'm writing in the Jamboard. Case when n is equal to 2. तो n is equal to 2 केस में x and fx values क्या क्या होगा? x0, x1, x2, and the functional values f0, f1, f2. तो what is the Lagrange's polynomial? Lagrange's or Lagrange's interpolation polynomial. Interpolating polynomial. It is denoted as Lx. What will be the degree of the polynomial? Can you tell me? What will be the degree? So as I told, if there are n plus 1 number of nodes, then the degree of the polynomial is n, right? So here, how many nodes? 3 nodes. So what is the degree, or what will be the degree of the interpolating polynomial? Tell me. 2, right?
Yes.
Okay. So it will be 2. मतलब एक वो ax square plus bx plus c वाला polynomial है. Now what is the rule here? You write the formula k0 to n, n means 2, lk x divided by lk xk into fk. So there are 3 terms here. k0 के लिए, k1 के लिए, k2 के लिए, 3 terms. Now for k0 l not आएगा. l not x क्या होगा बोलो? What is l not x? l not x means x minus x not is absent. So what are the terms here? X minus x1 and x minus x2. These two, product of these two linear factors. Then L1x. In L1x, x minus x1 absent. It is missing, right? So x minus x not रहेगा, x minus x2 रहेगा. And L2 up to maximum L2 ना, ये 0 to 2 है, तो L0, L1, L2 up to L2 construct करना पड़ेगा. तो L2x will be x minus x2 missing, so x minus x not multiplied x minus x1. Now you find the denominator values lk xk. So l not x not, what it will be? In L naught x, it is simple. In L naught x, you put x equal to x naught. You will get L naught x naught. So it is x naught minus x1, x naught minus x2. Next, for k is equal to 1, it is L1 x1. So in L1 x, you put x equal to x1. x1 minus x naught multiply x1 minus x2. And L2 x2, it will be similarly x2 minus x naught, x2 minus x1. Therefore, what is Lx? What is Lx? Ultimately, term wise, if we write, it is L naught x divided by L naught x naught. So x minus x1, x minus x2 divided by x naught minus x1, x naught minus x2, f naught. Next term will be x minus x naught, x minus x2 divided by x1 minus x naught, x1 minus x2, f1 plus x minus x naught, x minus x1 divided by x2 minus x naught, x2 minus x1 multiplied f2. So if we split this summation and if we substitute L naught x, L1 x, L2 x, L naught x naught, L1 x1, L2 x2, we will get this. Okay. So that is the final form of this Lx. Now here, after that you simplify it. See, the denominators are constant. F naught, F1, F2 are constant. Only you have to multiply this to this. In these 3 terms, you multiply these factors. and then add them. It will be a quadratic polynomial. You simplify it, it will be something into x square plus something into x plus a constant. Fine. So it is a process to find interpolating polynomial. Now if it is asked find f at some value which is not in the table, okay, f at some value x, say xm, okay, xm which is not in the table. So what you will do after finding the interpolating polynomial, up to this, after doing up to this, you put x equal to that xm value, you will get the value of that. Okay, once we got the polynomial, once we got the function corresponding to the table, we can find any value of f corresponding to any value of x, right? So main task, again I am repeating, main task is to find the polynomial, is to construct the polynomial. Now you see, uh, there are some example. Yes, so we have the table, there have four values, right, four nodes. So x naught, x1, x2, x3, four values. So what will be the degree according to the
Three.
Lagrange's interpolation? The degree of the polynomial will be 3, right? Degree of the polynomial will be 3. जितना वैल्यूज रहेगा उससे एक कम होगा डिग्री, तो डिग्री विल बी 3. वो बाद में पता चल जाएगा, ये अभी अगर नहीं भी पता हो कि डिग्री कितना होगा चलेगा, कोई इशू नहीं है. एट लास्ट यू विल गेट द पॉलिनोमियल. तो again you write the formula this, and here n is equal to what, 3. 4 values मतलब n plus 1 4. Don't write n is equal to 4. Okay, मतलब total 4 values है, तो that is a value of n plus 1. n plus 1 4 है, तो n कितना होगा 3, तो n का value 3. So in that summation that n will be 3. Okay, so these are the nodes you denote x naught, x1, x2, x3, and these are f naught, f1, f2, f3. Okay, now one by one you can write directly also in that summation. So for k is equal to 0, देखो I have written directly actually. For k is equal to 0, first term I am writing first term. So first term will be L1 x, sorry, not L1. For k is equal to 0, L0 x divided by L0 x0 into f0. That is the first term. So L0 x means what? Product of all the linear factors except x minus x0. तो ऑल मतलब टोटल तो 4 है, 4 फैक्टर होगा. अब उसमें x माइनस एक्स नॉट नहीं है, तो क्या क्या रहेगा, x माइनस एक्स वन, x माइनस एक्स टू, x माइनस एक्स थ्री, दैट इज L नॉट. नाउ व्हाट इज द डिनोमिनेटर इन L नॉट x? यू पुट x इक्वल टू x नॉट. तो ऊपर ये न्यूमरेटर देख के न्यूमरेटर में x के जगह पे x नॉट पुट कर दो इन एवरी फैक्टर, यू विल गेट द डिनोमिनेटर. तो यहाँ पे मतलब देयर आर पैटर्न, यू कैन डायरेक्टली राइट. ओके, अलग से एल के एक्स क्या है, एल के एक्स के क्या है, वो लिखने का जरूरत नहीं है, यू कैन राइट इट डायरेक्टली. तो एल नॉट एक्स विल बी एक्स माइनस एक्स वन, एक्स माइनस एक्स टू, एक्स माइनस एक्स थ्री, and L naught x naught will be x naught minus x1, x naught minus x2, x naught minus x3. In the numerator, I am putting x equal to x naught to get the denominator. That's all. So first term हो गया. Then for k is equal to 1, for k is equal to 1, second term. So k is equal to 1 means L1 x divided by L1 x1. Now L1 means x माइनस x1 फैक्टर इज नॉट देयर। तो देखो x माइनस एक्स नॉट है, x माइनस x2 है, x माइनस x3 है, x माइनस x1 इज नॉट देयर, राइट। तो ये हो गया। देन यू पुट x equal to x1 in L1x, you will get the denominator. Similarly, you write the third term, you write the fourth term. यहाँ पे टोटल 4 टर्म है, k0 के लिए, k1 के लिए, k2 के लिए, k3 के लिए। ओके, यू कैन राइट वन मोर लाइन हियर। मतलब अगर समेशन को स्प्लिट करेंगे तो क्या होगा, L नॉट x डिवाइडेड बाई L नॉट x नॉट f नॉट प्लस L1x divided by L1 x1 into f1 plus L2x divided by L2 x2 f2 plus L3x divided by L3 x3 to f3. You can write this line. After that you substitute L naught, L1 x naught and this L functions and L values. So after putting, you see, after putting x1 x2 x3, now I am substituting. Okay, that is according to the function we got, according to the formula we got. Then you put ये x naught है, ये x naught है, ये x1 है, ये x2 है, ये x3 है। तो substitute these values. I am substituting. See, ultimately after simplifying, I am getting that x cube plus x square minus x plus 1. So it is what? It is a cubic polynomial. So which is satisfying, as I told, that if there are n plus 1 number of nodes, you will get at most degree n polynomial. So here we are getting degree 3 polynomial. There are 4 nodes, so I am getting degree 3 polynomials. I may get degree 3 less also, but here I am getting degree 3. That is a polynomial. Now after that, if someone asks, मतलब ये तो बस ये क्वेश्चन का आंसर हो गया कि व्हाट विल बी द लैग्रेंजेस इंटरपोलेटिंग पॉलिनोमियल। ओके, नाउ इफ आई आस्क along with this question, if I ask what is the value of say 2.7, what is the value of 2.7? So what you will do, we got the polynomial, so that is our fx actually, fx which is equivalent to lx. So that is basically fx. ये fx का मतलब वो corresponding polynomial है। तो here if you put x equal to 2.7, you will get the answer 2.7 whole cube plus 2.7 whole square minus 2.7 plus 1. You simplify it, you will get the value. Okay. Another problem, you see there are 3 nodes. So 3 nodes means you will get a polynomial of degree at most 2. Okay, so 3 nodes मतलब calculation more simple. So there are 3 terms in the summation, and those 3 terms are this product of 2 factors only, because 3 factors है, उसमें एक factor को हटाना पड़ेगा, तो product of 2 factors आएगा हर एक term में। After that you put the value of x0, x1, x2, you will get the polynomial. After simplifying, you will get the polynomial. And what is the question here? Find f at 0. यहाँ पे देखो, in that question they have not asked you to find the interpolating polynomial. Okay, they have asked you to apply Lagrange's polynomial to get the value of f at 0. मतलब x equal to 0 पे f का वैल्यू क्या होगा। तो प्रोसेस सेम ही है, मतलब ये यहाँ पे आके और सिंप्लीफाई मैं नहीं करूंगा। इफ दे आर नॉट आस्किंग द पॉलिनोमियल, वी विल नॉट सिंप्लीफाई इट। ओके, आफ्टर सिंप्लीफाइंग दैट लाइन वी विल गेट द पॉलिनोमियल in the form a not, मतलब something into x square plus something into x plus something, ऐसे फॉर्म में वो पॉलिनोमियल मिल जाएगा। बट क्योंकि यहाँ पे वो पॉलिनोमियल पूछा नहीं है, दे हैव आस्क्ड यू टू फाइंड ए पर्टिकुलर वैल्यू, तो ये लाइन के बाद मैं डायरेक्टली वो वैल्यू निकल रहा हूँ, क्योंकि सिंप्लीफिकेशन करने में थोड़ा टाइम जाएगा, तो वो सिंप्लीफिकेशन करने का जरूरत नहीं है अगर पॉलिनोमियल नहीं पूछ रहा है तो। देखो, तो यहाँ पे दो टाइप का मैं पॉलिनोमियल में मतलब इंटरपोलेशन में दो टाइप का क्वेश्चन है। एक है, फर्स्ट ऑफ ऑल इट मे बी आस्क्ड दैट व्हाट इज द इंटरपोलेटिंग पॉलिनोमियल, देन यू फाइंड ए वैल्यू, or in some question they may ask directly to find the value, not the polynomial. Okay, so in that case you can do that step jump actually, मतलब ये पॉलिनोमियल सिंप्लीफाई करके अगर करोगे तो कोई इशू नहीं है, बस वेस्टेज ऑफ टाइम होगा। ये स्टेप के बाद डायरेक्टली तुम x का वैल्यू पुट करो जिसमें वैल्यू पूछ रहा है, जैसे कि x इक्वल टू 0 पे वैल्यू पूछ रहा था, तो ये जो लास्ट एक्सप्रेशन अंडरलाइन एक्सप्रेशन है, यहाँ पे मैं x इक्वल टू 0 पुट कर दूंगा तो आई विल गेट द वैल्यू। कोई अगर इसको सिंप्लीफाई करके पॉलिनोमियल फॉर्म में लिखता है, देन ये वैल्यू पुट करता है, he or she also get the same answer, बट उसके लिए टाइम ज्यादा लगेगा और क्या। बट अगर क्वेश्चन में पॉलिनोमियल क्या है ये पूछ रहा है एंड यू आर नॉट सिंप्लीफाइंग, मतलब ये क्वेश्चन में अगर ये पूछता कि व्हाट इज द लैग्रेंज इंटरपोलेशन एंड यू डू दिस कैलकुलेशन, देन यू विल गेट लेस मार्क, क्योंकि इसमें पॉलिनोमियल जो है वो ये फॉर्म में दिखाना दैट इज नॉट एक्सेप्टेड, क्योंकि पॉलिनोमियल यहाँ से पॉलिनोमियल क्या है वो पता नहीं चल रहा, यू हैव टू सिंप्लीफाई इट एंड शो। Okay. So that's all about Lagrange's interpolation. In the next class, we will discuss on uh, Newton's divided difference interpolation. Okay. Any doubt regarding that Lagrange's interpolation?
No, sir.
Okay. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. See you on next class. Thank you, sir.